Okay, so this next example is a build-up of the previous one. It says 3 cars. It's all really one car. We're assuming the car is driving along, and your brain actually, your eyeballs actually see the car at t equals 0, and your eyeballs see the car at t equals 2. But what happens is your brain infers where the car was at t equals 1. So your eyes aren't actually seeing it. There's some kind of saccades going on, or maybe you blinked, or whatever happened. You did not physically see that car, but your brain recreates it. So that's the thing I'm going for here. And what I wanted to do is build the sheaf so that these 2 cars could somehow come together and create this car in the middle. And we tried that several different ways, and it didn't work. And it's kind of obvious in retrospect why it wasn't working. But let me sort of explain what I think will help. We're not getting success on this because when you follow these different, if this is representing some kind of a digraph, if you're trying to go from this eye to this car to this car, you don't have enough information to actually get to this intermediate car. You're sitting at this car, and how would you know where this image is going to end up? So one thing you could do is you could put a velocity and a position on this car. If you wanted to do that, then this eye would be perceiving not only the car, but the speed at which it's going, and will predict where the car will be. And then this next time the car is viewed, you'll also see a velocity and a position, and you could reverse engineer where the car must have come from. You would then have your path independence because you could come around this way and see the car, or you could come around this way, and you should get roughly the same solution, and that would be a perfectly reasonable way to proceed. But what if that's not really what your data are? What if you don't have velocity data, you just have position data? Then you really can't just sit at this car and guess where the car is going to end up. You actually have to combine information from both branches as you're coming together, and that's kind of hard to do. So what we're going to do instead for this example is we're going to actually code it up with a headquarters node where all the information we know is in the headquarters, and it can dispense it appropriately. So from headquarters, the headquarters actually knows the position of the 2 vehicles, and then actually spreads all that information out. Tells vehicle 1, here's where you are. Vehicle 2, here's where you are. Vehicle 1, you're actually halfway between these 2 vehicles. And eyeballs, this is what you're seeing. And so that is one way to get around that problem. And that's the model that we're going to be using in the code. And I actually did decide to draw all 4 eyeballs this time just to be fun. Okay, so you can look at the code here. The headquarters cell has 4 dimensions because it holds the information for the 2 cars that are actually being seen. And the data dimension for the cars is just 2 each. Now there's linear dependence because V1 is just halfway between the other 2 cars, but that is fine. And then you have your eyeballs, and notice there's no eyeball at time equals 1 because the eye isn't actually seeing anything at time equals 1. All right, and so I go ahead and code this whole thing up with arctans, and again, just like last time, I do need that weight because I have both angles and distances, and I need a way of deciding which one needs to be more important, or adjusting the relative importance of all that. And just for fun, I started everything off at 0. Headquarters, I started everything off at 0. The only thing that got hard-coded in that wasn't optimized was the angles viewed by the eyeballs. That one cannot be changed because that is the experienced angles. That's our actual data. Everything else was just throwaway data. And let's see if we actually ended up locating our cars. And okay, lovely graph. Okay, so again, I just typed this in so that every time I run the code, I can remember where it was that I hid those cars. And did I find the cars? Okay, it looks like I found the cars. I'm not really thrilled, to be honest, at this V2. It is not exciting to me. It's not in a great place, but it's not horrible either. So I don't know, maybe I will just cheat a little bit and move that along closer to where it's supposed to be. Maybe I'll move this guy a little closer to where it's supposed to be and see if that makes any difference. And go ahead and run that code, and that just kind of gives me a sense for how robust the code is. And let's see, V0 is fine, V2 is a lot better. Yeah, so that might be something I need to just adjust the number of iterations. That might fix the problem. I promised to tell you how to do that, and then I didn't, but that information will be forthcoming. And yeah, that is about it for that example.